Hello and welcome. In this video, we're going to be taking a look at the solutions to the homework section of Unit 3, Lesson 4 on finding zeros using completing the square. Let's begin. For number 1, we're solving the equation x squared minus 4x minus 12 equals 0 two ways. Part A, by factoring, and part B, by completing the square. Now, the factoring method that I will choose to show is the x factor method or the cross method. Again, just to review it, when you have a perfect square, a trinomial, that's written in standard form, the leading coefficient is the number in front of a, b is the coefficient in front of x, and c is the coefficient by itself. Now, when we use the x method or the cross method, what we do is we place a times c on top of the cross and we place b on the bottom of the cross. Then you look for two numbers, here and here. These two numbers have to multiply to get a times c, and they have to add to get b. Let's practice this. Here's our quadratic. Our a term is 1, our b term is -4, and our c term is 12. So our a times c would be 1 times -12. -12 goes up top. -4 is our b term. That goes on bottom. The two numbers here have to multiply to give -12 and add to get -4. So I like to start off with my products, my factors of -12. What are my factors of -12? Well, -12 and 1, or 12 and -1. I could do 4 and 3, or -6 and 2, or 6 and -2. I could do -4 and 3, right, or 4 and -3. And I believe that's it. Now, out of these, which are the only ones that are going to add up to -4? Well, specifically, it's going to be this one right here, -6 and +2. So all I do to complete the factoring is I slap on an x in front of these, and this becomes x minus 6 times x plus 2 equals 0. Now, to actually solve it, we're going to use the zero product property, which means we take each one and set them equal to 0. So the first one is going to be x minus 6 equals 0, or x plus 2 equals 0. And we solve each one. And our solution set would be x equals 6 or x equals -2. How about solving it by completing the square? Well, the equation was x squared minus 4x minus 12 equals 0. Remember, ladies and gentlemen, when we complete the square, we only complete the square on the first two terms. So what I like to do is separate the first two terms from that -12. So this is going to be x squared minus 4x plus, and then leave a little space there. Okay, I'll put the -12 way over here. So I'm basically taking the equation that we have, and I'm going to stretch it out a little bit. Now, what goes here? What goes here in this term? The term that goes here is b over 2 squared. Now your b term is negative 4. That's your b term right there. So b over 2 squared, in this case, would be negative 4 divided by 2 squared. Well, negative 4 divided by 2 is negative 2, and negative 2 squared is positive 4. So I'm going to add a 4 to this to make this a perfect square trinomial. But then if I add that 4, I have to complete this by subtracting 4. So really, I'm adding 0. The next thing I'm going to do is I'm going to section off this with parentheses, and I'm going to rewrite that as a perfect square binomial of x minus 2 quantity squared. So this is the same as this. Minus 16 equals 0. We're going to add 16 to both sides and rewrite. X minus 2 squared equals 16. Go ahead and square root both sides. And we get x minus 2 equals plus or minus 4. So adding the 2 both sides, we get x is equal to 2 plus 4, which is 6, and x is equal to 2 minus 4, which is negative 2. Those are our 2 solutions for this equation. And you'll notice we got them 2 different ways. Number 2. So by factoring, a is 1, b is 10, c is 21. So to complete the cross, a times c would be positive 21, and b would be 10. Now what are our factors that give us 21? Well, those would be 1 and 21, or 7 and 3. So this would be x plus 7 times x plus 3 equals 0, because 7 and 3, of course, would add up to positive 10. Set each factor equal to 0 and solve. And our first solution is x equals negative 7, or x equals negative 3. Now, completing the square on this, again, we're going to take this trinomial, but we're going to spread it out. So x squared plus 10x plus, leave some space, plus 21 equals 0. Again, what goes in that space? b over 2 squared. Well, b is 10, so let's go 10 divided by 2. That would be 5. Square 5, we get 25. So I'm going to be adding 25 here, but I must also subtract that same amount. We'll section off this group part here, and that becomes x plus 5 quantity squared minus negative 25 plus 21 would be minus 4 equals 0. Let's go ahead and add 4 to both sides. And if we rewrite this, we get the quantity of x plus 5 squared equals 4. Square root both sides, plus or minus the root 4. And x plus 5 is equal to 2, or x plus 5 is equal to negative 2, plus or minus square root of 4. Go ahead and subtract 5 from both sides. and we get x is equal to negative 3, or x is equal to negative 7. Again, same solutions. Part 3. Find the solutions of the equation in simplest radical form by the technique of completing the square. Simplest radical form means we need our list of perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Okay, here we go. Start off by spreading this out. X squared plus 8x plus a number, and then minus 2 equals 0. So you basically want to make some space. So plus a number minus that same number. So that number there, of course, would be b over 2 squared. So b is 8. Let's go 8 divided by 2. Ladies and gentlemen, 8 divided by 2 is 4. Square that and we get 16. So we're going to add 16 here. Subtract the same amount. Let's section this off. And this becomes x plus 4 squared. So this right here becomes x plus 4, quantity squared, minus 18 equals 0. Add 18. And rewrite this. And we get x plus 4 quantity squared equals 18. Square root both sides. And if we look, ladies and gentlemen, the largest perfect square root that goes into 18 would, of course, be 9. This becomes x plus 4 is equal to plus or minus the square root of 9 times 2. Well, that's x plus 4 is equal to plus or minus the square root of 9 times the square root of 2. Take the square root of 9 to get 3. We have x plus 4 is equal to plus or minus 3 radical 2. And the last step, subtract 4 both sides. And our solutions, our two solutions, would be x is equal to negative 4 plus or minus 3 radical 2. Now, in number 4, we're going to complete the squares and find the zeros of this function. So to find the zeros of the function, we need to essentially let f of x equal to 0. So let's do that. 2x squared plus 12x plus 5 equals 0. But recall, guys, when you are completing the square, you only do it on the first two terms, and completing the square only works when the lead coefficient is 1. Clearly, you can see the lead coefficient is 2. It's not 1. So we have to factor out that lead coefficient. So let's do that. This is going to be 2. If we factor out a 2 from 2x squared, we get x squared. Plus, if you factor out a 2 from 12x, we get 6x. Plus some space, leave a space. And I'm running out of room here. Let me make it a little smaller. Make it fit. There we go. Okay, plus 6, leave some space. Okay, and then we're going to be subtracting 2 times whatever that number is. So let's figure this out. The number here that goes here is b over 2 squared. So b is 6. Everybody go 6 divided by 2. We get 3. 3 squared is 9. Now, we are not subtracting 9. We are subtracting 9 times 2, because remember, you're multiplying times 2. So 9 times 2, right, and then the plus 5. Equals 0. This would become 2. That perfect square trinomial would be x plus 3 squared minus 18 plus 5 equals 0. Let's take care of that. 2 times the quantity x plus 3 squared minus 13 equals 0. Let's go ahead and add 13 to both sides. And we get 2 times the quantity x plus 3 squared equals 13. Let's go ahead and divide by 2 before we square root. And we end up with the quantity of x plus 3 squared equals 6.5. Well, now we have to take the square root of both sides. So plus or minus the square root of 6.5. Okay, but here's what we're going to do. Since we need to round this to the nearest hundredth, what we're going to do is we're going to wait to do the rounding at the very end. For now, let's write them as exact answers in simplified form, and then we will round it out with our calculator. So in other words, this becomes x plus 3 is equal to plus or minus the square root of 6.5. Subtract your 3 and then put it in the calculator. This becomes x is equal to negative 3 plus the square root of 6.5, which is approximately, put that in our calculator, negative 3 plus the square root of 6.5, and we get about negative 0.45. So that would be one solution. Or x is equal to negative 3 minus the square root of 6.5. Right? That's the other solution. Put that in your calculator as well. Negative 3 minus the square root of 6.5 is approximately negative 5.55. Let's take a look at number 5. Consider the quadratic function shown below whose leading coefficient is equal to 1. Well, we need to be able to identify stuff from that particular graph. Now, the equation itself can be modeled in what's called vertex form. This is called vertex form. Sometimes it's called HK form. This is the x-coordinate of the vertex. This is the y-coordinate of the vertex. So I look at my graph, and my vertex is actually right there. It's that spot right there. And the vertex there has the coordinates 1, 2, 3, 4, 5, 6, 1, 2, 6, negative 2. So there's my H, and there's my K. The equation would be y equals 1. We have a leading coefficient equal to 1, so 1x squared, or simply x, minus 6, quantity squared. 6 is my H, plus a negative 2. Now I would just rewrite this as y is equal to quantity x minus 6 squared minus 2. That will be my equation in vertex form. Now, how do I find the zeros? Well, to find the zeros, what do? Set y equal to 0 and solve for x. So we're going to go x minus 6 equals 0 minus 2 equals 0. Let's begin this by adding 2 both sides. And we get quantity x minus 6 squared equals 2. Take the square root of both sides. And we get x minus 6 is equal to plus or minus radical 2. And we'll go ahead and add 6 both sides. So the x-intercepts, or the zeros, would be at 6 plus the square root of 2 and x equals 6 minus the square root of 2, right? Or you could simply write it x is equal to 6 plus or minus square root of 2. Let's write the equation of this quadratic function in standard form. Well, how do we do that? We simply have to multiply this out and expand it. So let's write that down. Y is equal to x minus 6 squared minus 2. Now the first thing we're going to do is we're going to write that expanded out. So y is equal to, if we're writing something squared, that would be x minus 6 times x minus 6. And then, of course, minus 2. Now, when you're multiplying two binomials together, essentially what you do is you multiply the outer term times each of the inner terms. You distribute the outer term times each of the inner terms. It's very much the same way you would distribute 2 to x minus 4. You would distribute the 2 to the x to get 2x minus the 2 times the 4 to get 8. So you're going to do very much the same thing. We're going to be distributing x minus 6. So I'm going to write x minus 6 times x minus, again, I'm going to write x minus 6, and then the 6, the second term. So I just distribute the x minus 6 to both of these terms here. Now I multiply through. X times x is x squared minus 6x. So I get x squared minus 6x. And then over on this part here, we get minus 6x minus 36. So minus 6x, 6x minus 36. And then I'm just going to distribute the negative to both sides there, and we get y is equal to x squared minus 6x minus 6x plus 36. And then add those together, y is equal to negative 12x plus 36. Sorry, I completely forgot the x squared term there. X squared minus 12x plus 36. Number 6. Consider the quadratic function x squared plus 2x minus 48 written in standard form. Write the quadratic in vertex form, stating its coordinate points of the vertex, of the turning point. So we would do that by completing the square on the first two terms. So let's do that. Y is equal to, we're going to go x squared plus 2x plus, leave some space, right? And then minus 48. Well, what's that space that we're leaving? Well, remember, guys, it's b over 2 squared. B is 2, so let's go 2 divided by 2, that would be 1. Square it, 1 squared is 1. So we're going to be adding 1 here, but we have to subtract the same amount. Okay, section that off. And this becomes y is equal to a perfect square binomial of x plus 1, quantity squared, minus 49. This can be rewritten as y is equal to x minus a minus 1 squared minus 49, which helps you identify this is your h, this is your k. And the vertex is always written as hk. Negative 1, negative 49. Find the zeros of the function. Well, got to set it equal to 0, right? So the function would be x plus 1 quantity squared minus 49, but we have to set that equal to 0. And simply solve it for x. Add 49 both sides. X plus 1 quantity squared equals 49. Plus or minus square root both sides. X plus 1 is equal to the square root of 7, plus or minus 7, excuse me. We'll subtract 1 both sides. X is equal to negative 1 plus 7, or 6. And x is equal to negative 1 minus 7, or negative 8. Part C. State the range of this quadratic equation and justify by creating a sketch of the function from what you created in A and B. Okay, the range of the function would be all y values. The domain is all x values. The range is all y values. Well, the lowest y value is the vertex, which has a y-coordinate of negative 49. So that means the y is going to be greater than or equal to negative 49. Now we'd write that in bracket notation of negative 49. The bracket tells you you can include negative 49 to all numbers greater than that, which would be infinity. Right? You could write it like this: all numbers greater than or equal to 49, or you could write it like this. Letter D. This quadratic can also be written as an equivalent factored form of y is equal to quantity x minus 6 times the quantity x plus 8. What graphical features are easy to determine when the function is written in this form? Well, what's easy to tell? The zeros. The zeros are easy to find. Here's what I mean. If we were to take this form right here, we would get y is equal to x minus 6 times x plus 8. And if you were looking for zeros, what do? We set y equal to 0 and solve for x, right? Well, that would mean x minus 6 times x plus 8 equals 0. Well, x minus 6 equals 0, and x plus 8 equals 0. And if we were to add 6 both sides, subtract 8 both sides, we would get 6 and negative 8, which you found to be the zeros that we did in part B. So this is just a way of kind of reminding you, hey, if it's in factored form, it's very easy to find the zeros. We just simply use the zero product property, the ZPP, and set each factor equal to 0 and solve. Number 7. Find the zeros of the function y is equal to x squared minus 4x minus 2 in simplest radical form. Based on this answer, how do you know that you could not use factoring to find these zeros? Okay, so let's complete the square on this. Complete the square on the first two parts of this, so y is equal to, and actually we should set this function equal to 0. So x squared minus 4x plus a number, and then minus 2 is going to be equal to 0. Remember, to find zeros, you set your y equal to 0 and solve for x. What goes here? Well, b over 2 squared goes there. So there's our b term. Negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So we're going to add 4 here, but we have to subtract that same amount. Section this off. This becomes x minus, square root of that would be 2 squared, minus 6 equals 0. Well, what do we get? We have x minus 2 quantity squared minus 6 equals 0. Well, I'm going to add 6 both sides, and so that's equal to 6. Let's go ahead and take the plus or minus square root of this, both sides. And we get x minus 2 is equal to plus or minus radical 6. Go ahead and add 2 to both sides. And we get x is equal to 2 plus or minus radical 6. Now that's our answer. That's our solution. But it says, based on this, how do you know you could not factor? We cannot factor because the solutions are irrational. You can only factor rational solutions. Okay? Irrational, all zeros found by factoring are rational numbers. These are clearly not rational, therefore this trinomial is not factorable.